Good morning, Geometry iPad Initiative students. This is your last lesson on the iPad this semester. This is section 7.4. This is properties of similar triangles. Make sure you get the title and number 5 down and answered. So good luck with this one. I'll be expecting notes on this right away because your iPads are due tomorrow. Alright, we've got the first theorem here. There will be a lot of theorems on this, by the way, which is the triangle proportionality theorem. It says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Got a picture over here that goes along with it. And basically what it's talking about is these two lines are parallel, so that this segment right here, let me get a pen here. This segment right here, if I put this over this, then this over this is true. So these are proportional. So in other words, x over y would equal c over d. And what they'll do for problems is they'll leave one of these out, like c or something, and give us all the rest in numbers. So this would be your variable, and you'd cross multiply to solve it. I think we have an example right down here of that. Okay. So let's see here. We got these two parallel lines. So I got what? 10 over 4 is equal to what? 14 over, I label that x. So again, all we do is cross multiply here to solve. So 10x is equal to, let's see, what is that? 16, carry that, be 56. So when I divide by 10, it looks like x will equal 5.6. Alright, that was not too bad. Let's see, I think we got another one just like that here. And let's see, we're going to put 5 over 2 is equal to, this time, x over 3. So it looks like we're going to have what? 15 is equal to 2x. So when I divide by 2, it looks like x will equal 7.5. Right, there's some problems there. Alright, converse of the triangle proportionality theorem. Remember that the converse is flip-flops a conclusion with the hypothesis. So this one's going to say something about the sides being proportional. Then we can prove that the lines are parallel. So in other words, if we set up a proportion this to this over this to this, and it comes out, if we reduce both sides and it comes out to be the same thing, then these two lines would have to be parallel right here. Okay, see if we got an example. Verify that DE is parallel to BC. So all I'm going to do is put 8 over 12 equals what? 10 over 15. So a couple ways I could do this, but I think I'm just going to reduce the fractions here. So if I pull a 4 out, I'll have a 2 over 3, and pull a 5 out, I'm going to have a 2 over 3. Alright, so now we have another little example here. It says that this full length here is 36, and it says that this length here is 27. So all we got to do is a little bit of subtraction here. So if this full length is 27, that's 15. This has got to be 12, right? And if the full length here is 36 and that part of it's 20, this has got to be 16. So now I can set up 15 over 12 as 20 is to 16. And let's see, if I pull a big 3 out of this, I think I'll have a 5 over a 4. And let's see, a 4 out of this would be a 5 over 4. So these two lines must be parallel then. Alright, there looks to be some more problems there. Bam. Alright, next one says the two transversal proportionality. It says if 3 or more lines are intersect two transversals, such as this. We got 3 lines. These are the 2 transversals. Then they divide the transversals proportionally, which would mean that AC is to CE as BD is to DF. And I think we got an example right down here of this. It says there's an artist decided to make a larger sketch of the trees in the figure. I think it's got labeled here for us. Everything that says. It says find LM. So let's just do that first. So we're going to have 4.5 over 2.6 as 4.9 is to x. So we got, well, when we cross multiply, that would be 4.5x equals, it looks like we're going to have to break the old handy dandy calculator out here real fast. So we're going to have 4.9 times 2.6. And that's going to be what? 12.74. So we're going to have to divide that 4.5. So that divided by 4.5. And we're going to have x is equal to, what was that again? 2.83 to the nearest tenth of an inch, so it looks like just 2.8 inches. Alright, and then we need to find the other little segment that's missing here. I always like to go back to the information that we know in setting this up. So in other words, for this particular problem, I think we want to go back to the 4.5 is to 4.1 this time, as our 4.9 is to what we're going to call x. And now we can just cross multiply to solve that. And it's pretty much the same thing we just did with the other problem. So let's see, we got 4.1 times 4.9. We got 20.09. We got 4.5 over 4.5. And back to the old handy dandy calculator. Let's divide that by 4.5. And to the nearest tenth, we're going to have 4.5. Okay. Alright, let's move on. That wasn't too bad. Looks like the same problem we just worked here. Just different lengths, so I think we're good there. Alright. Next theorem is the triangle angle bisector theorem. Hopefully you remember what an angle bisector is. Notice that we got an angle bisector here. The actual theorem says an angle bisector of a triangle divides the opposite sides into two segments whose side lengths are proportional to the lengths of the other two sides. So notice that this is to this as this is to this. So I think we got an example right over here of that. Let's go ahead and jump right into it. Alright, so here we go. We're going to say x plus 5 is to x minus 2. So this is to this as this is to this, which will be 40 is to 32. And I'm just going to reduce this over here before we really get started on the problem to help us out a little bit. So I'm going to say, let's take an 8 out of that. So actually I'll have a 5 over 4 is equal to x plus 5 over x minus 2. Secret word for today, we're going to go back to some fruits here. We're going to say strawberry. Alright, so we're going to have what? Let's extend this. When we distribute here, we're going to have 5x minus 10. When we cross multiply that. When we cross multiply the other side, we're going to have 4x plus 20. So I'm going to subtract the 4x. That will just give me x. I'm going to go ahead and add this 10, which will give me 30. And are we supposed to actually find the side length? Yes. So that means we got to plug x back into these. So 30 plus 5 would be 35 for this length. And when I plug it back into this one, I'll have 30 minus 2, which will be 28. Okay. Alright, another one just like that. We're going to jump past. Alright, there we go. And that looks like we're going to conclude this lesson. So, Mr. Lane signing off for the last time from OHS High School for this year. See you on. Yep. Have a good rest of the year. Good luck on your tests and quizzes. And we'll continue on with the iPad class as a regular class.